Example 4. We're going to write a system of equations to describe the situation below and then solve the system to answer the questions. Two political activists, Mandy and Ellie, have a friendly bet to see who can get the most signatures on a petition. So far, Mandy has collected 90 signatures, while Ellie has collected 62 signatures. Mandy is averaging 2 new signatures per minute. Wow. While Ellie is managing to collect an average of 3 signatures per minute. Wow. Assuming this trend continues, they will have a tie before long. How many signatures will each one have at that point, and how long will that take? Let's see what's going on here. We have Mandy and we have Ellie. So they're in a friendly little competition. Let's see what we know. So Mandy has collected 90 signatures so far, while Ellie has collected 62 signatures so far. Mandy is averaging 2 new signatures per minute, while Ellie is managing to collect an average of 3 signatures per minute. All right, so it's very important to know who gets which numbers. So I've color-coded them here while speaking them out so that you can see Mandy is working with 90 and 2, while Ellie is working with 62 and 3. So what is the pattern and what's already happened? Mandy is getting 2 new signatures per minute. This is happening again and again and again. All right, so we know that this 2 is very much her pattern, which means that this 90 signatures is what she had at the start of this friendly wager. Thus, Mandy's equation will be y equals a pattern of 2 signatures for every minute, in addition to the 90 that she's already got. While Ellie, on the other hand, she's averaging 3 signatures a minute. Again, we have the hint word of per, so this is Ellie's pattern. And we know that her friendly wager started at 62. Therefore, Ellie's equation will be y equals a pattern of 3 signatures for every minute plus the 62 she had at the beginning of our friendly little bet. Again, our equations are both y equals, and solving these systems of y equals is very easy and friendly and systematic. So that gives us an equation of 2x plus 90 equals 3x plus 62. Let's go solve for x. I'm going to subtract the smaller quantity of x's across the river. So let's subtract 2x, giving us a result of 90 equals 1x plus 62. After I subtract the 62 on both sides of the river, we find that 90 minus 62 is 28. Okay, so now that we know that x equals 28, I'm going to put that into, my top equation. Why not? Y equals 2x plus 90. And we're going to substitute this 28 right there for the x. As a result, we'll have y equals 2 times 28 plus 90. Let's find out what y equals. 2 times 28 makes 56. Plus that 90 is y equals 146. Okay, let's go solve some questions, answer some questions. We were asked to determine how many signatures each one will have at this point and how long that took. So you say, okay, what makes sense? Does it make sense to say, the number of signatures? Well, there's 28 of them, And that took a total amount of 146 minutes. Or does it make sense to say, oh, well, there was 146 signatures and it took me only 28 minutes to go get them? This little set of numbers might be a little bit confusing to you. I think the knee-jerk response would to say, oh, well, it couldn't be 146 signatures, but truth be told, it is. How do you know? Well, we know that Mandy had 90 signatures at go, and Ellie had 62 signatures at go, which means that 28 is not nearly enough, as it is less than both the 90 and the 62. So when they're done with the wager, they must both individually have more signatures than they did at the start. Therefore, we can conclude that there was a total of 146 signatures each, and that it took them 28 minutes to get them. Which, when you look back and say, oh yeah, she was getting 2 a minute and she was getting 3 a minute, they were getting a lot of signatures really, really quickly. So there you go.